Hello again. This is Brad Q with the second installment of my development video blog about my NES project, which has gotten renamed, as you can see. I'm now calling it Irkalla, which, according to Wikipedia anyway, is the Babylonian understanding of the underworld. And the whole story of the game kind of ties into that. I don't really have a whole lot to actually show you this week. All I've gotten is this reworked title screen, and I've been toying around with the title music a little bit. So I'll play a little bit of it for you. So trying to give it kind of a Middle Eastern feel to match with the Babylonian mythology. Originally I was planning on doing this project as NROM 256 because it doesn't need a scanline counter like the full screen Ultima style game would have. But I'm probably going to end up bumping that up to UNROM just so I can get some more graphical fidelity and more variety in the maps and whatnot. Sorry if I sound a little boring. I'm still sick and work's been just awful this week. So some of the other things I wanted to share with y'all is my assembler that I've written. QASM, which I've linked on the forums all over the place. But really I wrote this assembler for me and wrote it to my requirements. So, you know, it's probably not going to be a great fit for everyone. But it gets the job done for me. The main reason I decided to make my own assembler was that CA65 was hacking me off. I could not forward reference a scope. So referencing a scope before that scope is defined. An example is like right here. In the APU library, I need to call routines in the kernel, and also the kernel needs to call an update routine in the APU library. So if you have this situation in CA65, you have to do a lot of gymnastics to get around the scoping thing. Usually you just have to remove one or more of the labels from the scoping mechanism, and that kind of muddies the waters. So with QASM, you can forward reference a scope just like anything else. Another thing that I put in that is a big help to me is nested segments. So you'll see here I start my program ROM segment, and then I start including other files. So inside my main file, sorry, that's math. Inside my main file, I don't have to explicitly define a segment, and because that comes from the top level file. Let me show you a better example. So in the kernel library, I'm inside the PRG ROM segment, and when I want to declare a local variable for a routine, like here in my NMI vector handler, in CA65 I'd have to write this as an end segment and then start a new segment, 0 page, define my locals, end segment, and then switch the segment back to PRG ROM. For one thing, it's messy because it's not. It has to be above your procedure instead of inside of it. Secondly, you have to know what program segment you're being loaded into. And the advantage that this gives me is that this kernel library, if for some completely nonsensical reason I wanted to move it to another ROM segment, like the PRG ROM 2 segment, then all I would have to do is move the include, or even duplicate the include, either way, into another segment block like this. And now the same code can be reused. It can declare its local variables conveniently, and it doesn't have to be aware of what ROM segment it's actually entering. So those two concepts are kind of difficult to grasp unless you've used CA65 long enough to have run up on those problems. So if you haven't, great. If you have, you might want to give this one a look. Although I will say the macro handling is very basic in this. One other thing I've done is the segmentation is completely configurable. So you can define segments for RAM and ROM. They can overlap, they can share origins. You can set their length so that the assembler will automatically throw an error when you try to reserve, when you overflow that segment. For the ROM segments, you can also give absolute file offsets. So, well, I didn't say it earlier, but this is a one-shot assembler. So it takes all of your assembler source files and compiles it into a single binary. So this, you can place the ROM segments exactly where you want them. So you see right here, I've got the INES header going in at offset 0, program ROM at offset 16, character ROM at offset 32K plus 16, and then I can freely include my data wherever I want it. And as long as it's put in the right segment, it'll appear in the correct location in the file. So that's something that's helped me personally. One thing that I've found very useful about this setup right here is that I can share RAM. So like if I wanted to split my title screen and my game into two completely separate programs, then I can have a title RAM and game RAM segment that both overlap each other and use the same area of RAM. And then in my title code, I can declare variables inside of title RAM. In my game code, I can declare the variables inside of game RAM. And now we're using the same areas of RAM for different things, and the management of that sharing happens all right here in my segmentation header. The only thing you got to watch out for is you have to very clearly modularize your separate programs to make sure that they're not stepping on each other. And the final little feature that I threw in here that I really like, I'm not exactly 100% sure where I used it, so bear with me. I don't know. Well, anyway, I put in an alias command. So an example of that would be, a vector is a bad example. But like inside of this routine, if I wanted to declare a local variable, but I wanted to reuse a temporary variable, like is pretty common to use temp A, temp B, stuff like that. Instead of trying to remember what the heck temp A is supposed to mean inside of this routine, I can do an alias temp A and then give it a descriptive name like my local var. And so then later on I can say, I can refer to my local var just like any other label, and it will actually resolve to temp A. So that's just some of the major reasons why I implemented this assembler. Oh, I forgot. Where's a good example of this? The tiles. Finally, I also do data structuring. So this defines a data structure, sort of like a struct in C. The only limitation is that fields must be bytes. They can't be words. And then you can define static arrays like this in ROM and give it, give the data in row format. But then the assembler actually interleaves this stuff so that you can reference these rows by loading the index into X and then saying tileset dot flags X, and it will access row 1 flags because the assembler is actually interleaving all this data for me in the background. And there's also a directive that will do the same thing for a RAM segment. So you tell it struct, then the label like active tileset, tell it what structure it's based off of and how many you want in the array, and then you can it's just like this except that it exists in ROM, so you don't, or not ROM, it exists in RAM, so you don't have initializers, and you access it like just like you would. So this has saved me a lot of typing where I would normally have to write all these interleaved by hand. So this just kind of makes it look a little bit more like structured programming without actually enforcing some of those restrictions of structured programming. And there seems like there's one more thing I wanted to mention about the assembler, but I'm having trouble remembering it. So chances are it wasn't that important. So I guess I could talk a little bit about what I'm trying to do with the game. I'm looking at, I'm wanting to make it more action oriented than your typical Ultima style game, because I don't think that if I create an Ultima style game I'm going to enjoy playing it, because I'll already know where everything's at. So I'm going for a more action oriented game, probably somewhere along the lines of The Binding of Isaac, if you've ever played that. The Binding of Isaac is basically just a Zelda spin-off with projectiles instead of a sword. So I'm wanting to do something kind of like that with randomly generated dungeon layouts and things. So let me know what you think. Thanks. Bye-bye.